morning everyone, my name is Vishwas. Today we are going to do certain question answers of our chapter 10 of class 10, that is light. So define the principal focus of a concave mirror. What do you mean by principal focus? Light rays that are parallel to the principal axis. जो light rays parallel to the principal axis हैं, मिरर पे स्ट्राइक करने के बाद एक स्पेसिफिक पॉइंट पे आके कन्वर्ज करेंगी प्रिंसिपल एक्सिस के ऊपर, वो स्पेसिफिक पॉइंट को हम कहेंगे प्रिंसिपल फोकस ऑफ अ कॉन्केव मिरर, राइट. नेक्स्ट 20 centimeter. What is its focal length? So radius of curvature, that is r, is equal to 20 centimeter. In the previous video I have told you how to do these kind of numericals. The formula is f is equal to r upon 2 and r value they have already given to you, that is 20. What happens in this case is you put r is equal to 20, then f is equal to 20 upon 2, that is 10. So you can able to easily calculate the focal length of the spherical mirror, that is 10 centimeter, by the formula f is equal to r upon 2, or it can be r is equal to 2f, right? Name the mirror that can give an erect and enlarged image of the object. So ऐसा मिरर बताइए जो एक बड़ी इमेज बनाए और erect image बनाए, concave. Obviously how you can came to know that this is a concave mirror, when you will go by the cases that I have already explained to you in the previous video, you came to know. So if you haven't watched the previous video regarding the concave mirror cases, kindly go and watch on the YouTube channel edulearn.in, right? So why do we prefer a convex mirror as a rear view mirror in vehicles? That's the most important thing. We prefer a convex mirror as a rear view mirror in vehicles because it gives a wider field of view which allows the driver to see most of the traffic behind him. So basically whatever the mirrors we are having in our vehicles like Activas or cars, that mirror is called a rear view mirror, and they give us a very enlarged views of the traffic behind. But that mirror shows that the traffic is nearby us, right? That does not show the exact location of the traffic. That's why they have written on the mirror, objects in the mirror are seems to be closer than they appear, right? Appears to be closer than they appear. So convex mirror always form a virtual erect and diminished image of the object placed in front of it. So convex mirror हमेशा कैसी इमेज बनाएगा? वर्चुअल इरेक्ट एंड डिमिनिश, छोटी इमेज, तभी वो ज्यादा फील्ड ऑफ व्यू को एक पॉइंट पे कंसंट्रेट या फोकस कर पा रहा है, राइट. Now next is find the focal length of a convex mirror whose radius is 32. So r is equal to 32. Again the same formula, r is equal to 2f. Then you will calculate f is equal to r by 2. So 32 by 2, that is 16. You get the value of f, that is 16. So focal length of the convex mirror is 16 centimeter. In case of mirror or lenses, you can determine the radius of curvature of focal length by the same formula if one thing is given to you. Now the concave mirror produces 3 times magnified real image of the object placed at 10 cm in front of it. Where is the image located? This numerical I have already solved in the previous video that I have uploaded. So kindly go and check and just go through that video. So the same formula I have applied, and equal to h1 upon h, that is h height of object is equal to minus image distance upon object distance. So here they in the question only they have given you image is 3 times magnified as that of the object. If the height of object is h, then the height of image will be 3h, right? So in this case we are going to put down the value and we will get the value as minus 30 centimeter, right? Next is a ray of light traveling in air enters obliquely into water. Does the ray of light bend towards the normal or bend away from the normal? Why? The ray of light bends towards the normal. Why? Because when a ray of light enters from optically rarer medium to optically denser medium, its speed slows down and it bends towards the normal. उसकी speed थोड़ी कम हो जाती है और जिसकी वजह से वो normal की तरफ ज़्यादा bend कर जाती है. Since water is optically denser than air, so a ray of light entering air into water, from air into water, will bend towards the normal. This thing I have already explained along with the concept and diagrams in the previous videos. So light enters from air to glass having refractive index 1.50. What is the speed of light in the glass? So what happens in this case? Refractive index of medium, that is nm, is equal to speed of light in vacuum upon speed of light in given medium. So speed of light in vacuum कितनी होती है? 3 into 10 raised power 8 meter per second. और refractive index आपको दे रहा है 1.50. So you can easily able to calculate the speed of light in given medium by multiplying or dividing both of them, right? By this formula. Next is find out from table the medium having highest optical density. Also find the medium with lowest optical density. Now it is air, ice, water, alcohol, kerosene, right? So in which I have given you material medium and the refractive index of that particular medium. So through this table, we have to find out that in which these in which of these does the light travel the fastest. So light किसमें ज़्यादा तेज travel करेगी? लाइट ट्रैवल उसमें ज़्यादा तेज करेगी जो कि कम डेंसर होगा, राइट? सो कम डेंसर कौन सा है? In water, light travel faster as compared to kerosene and turpentine because the refractive index of water is lower than the kerosene and turpentine, and the speed of light is inversely proportional to the refractive index of the given medium. मतलब जितना ज्यादा refractive index होगा उतनी कम speed होगी. Refractive index कब ज्यादा होता है? जब वो denser medium होता है. For example, diamond has the highest refractive index that is 2.42. वो बहुत ज्यादा dense medium है जिसके अंदर light बहुत कम speed से travel करती है. The refractive index of diamond is 2.42. What is the meaning of this statement? Just now I have discussed कि in case of diamond, 2.42 refractive index means that in the speed of light in diamond is 2.42 times slower as that of the air, right? In other words, the speed of light in diamond is 1.42 times the speed of light in vacuum or air, right? Next is define one diopter power of the lens. So this is an important topic. What is power first of all? Power is defined as the ability of the eye lens to converge or diverge the beam of light. I'm again repeating it because this is not mentioned in the notes. I have not discussed with you. It is there in notes. Power is defined as the ability of the eye lens to converge or diverge the ray of light, right, in order to obtain an image on the retina or screen. So the SI unit of lens is diopter, which is denoted by the letter capital D, and one diopter is defined as the power of the lens of focal length 1 meter. One diopter power तब होगी जब उसकी focal length 1 मीटर होगी, क्योंकि पावर का फॉर्मूला होता है P is equal to 1/f. इसमें focal length आपने हमेशा meters में लेनी है. Either it is given in centimeters, you have to convert it into meters first. A concave lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. अब इसे क्वेश्चन को ध्यान से समझिए, बहुत अच्छा क्वेश्चन है. Convex lens forms a real and inverted image, right, of a needle at a distance of 50 centimeter from it. अब 50 सेंटीमीटर क्या हुआ? 50 सेंटीमीटर इसका इमेज डिस्टेंस भी है और 50 सेंटीमीटर इसका ऑब्जेक्ट डिस्टेंस भी है, राइट? सो फोकल लेंथ हमने f ले ली. अकॉर्डिंग टू द लेंस फॉर्मूला, हमने लेंस फॉर्मूला जब लगाया दैट इज 1/v minus 1/u is equal to 1/f, बिकॉज यहाँ पे मिरर की बात नहीं कर रहे, लेंस की बात कर रहे हैं. आप क्वेश्चन में भी देखें लेंस है, ठीक है. अब आप बोलेंगे सर आपने u और v दोनों ही 50 क्यों ले लिए? बिकॉज इसमें क्वेश्चन में आप देखिए given that image of the needle is formed at a distance of 50 centimeter from the convex lens, right? So 50 centimeter पे image form हो रही है, hence the needle is placed in front of the lens at the distance of 50 centimeter. मतलब image पीछे फॉर्म होगी तो ऑब्जेक्ट कहाँ पड़ा हुआ है? आगे, right? So u is minus 50 in this case and v is also 50. U is always minus. So in this case 1/v is equal to minus 1/u is equal to 1/f. If we have solved this, then we will get f is equal to 0.25, and after putting it in the formula p is equal to 1/f, we will get the final answer, that is plus 4 diopter. Plus sign indicates that it is a convex lens, right? I have already told you in notes. Find the power of focal length of concave lens of focal length 2 meter. इट्स वेरी सिंपल, 2 मीटर दिया हुआ है, इसको आप सेंटीमीटर में नहीं कन्वर्ट करेंगे, मीटर में ही रहने देंगे। फॉर्मूला लगाएंगे 1/-2 दैट इज -5 डायोटा, बिकॉज इट्स कॉन्केव पावर हमेशा माइनस होती है। Which of the following materials cannot be used to make lens? Because transparent नहीं होती. The image formed by a concave mirror is observed to be virtually larger. Where should be the position of the object? आप केसेस इसको देखें जरा कि कौन से सारे केसेस में से कॉन्केव मिरर में वर्चुअल इरेक्ट और लार्ज when the object is placed at between the pole of the mirror and its principal focus. तो ये वर्चुअल इमेज की बात कर रहा है, जो लास्ट केस है जो सेम साइड पे बन रहा है, राइट? Where should an object be placed in front of the convex lens to get a real image of the size of the object? So कहाँ पे हम ऑब्जेक्ट प्लेस करें जहाँ पे रियल इमेज बने? So it is at the twice of the focal length, that is at 2f, right? You can go through the cases once. A spherical mirror and a thin spherical lens have each a focal length of -15 centimeter. The mirror and the lens are likely to be concave, obviously, because it is having a minus focal length in minus, right? No matter how far you stand from a mirror, your image appears erect. This mirror is likely to be plane, concave, convex, either plane or convex. It's deep because it can be either of them. Because why it's either of them? Your image appears erect in both the cases, in both the mirrors, right? Either it's plane or convex. So you can use any of them at your home as well. Reading small letters found in a dictionary. So, in order to read the small letters found in the dictionary, we should use such kind of lens that help us to see small objects into larger images, right? So it's a convex lens of focal length 5 centimeter. You can solve it. And we wish to obtain an erect image of the object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror? What is the nature of the image? It's quite simple. The range of the distance of the object is equal to 0 to 15 centimeter from the pole of the mirror. Nature of the image is virtually erect and larger than the object, right? So this is the case which is getting formed. You can see the nature of the image. It's virtually erect and larger as compared to the size of the object, right? Now this is that we have done. That's a most important question, and the other important question is this. This is my favorite question. Name the type of mirror used in the following situations: headlight of a car, side or rear view mirror of a vehicle. Support the answer with reason. So हेडलाइट्स ऑफ द कार में हम कॉनकेव मिरर यूज करते हैं बिकॉज वो पावरफुल पैरेलल बीम ऑफ लाइट प्रोड्यूस करता है जब कोई भी लाइट सोर्स उसके फोकस पे रखते हैं हम लोग, ठीक है? तो फोकस से वो इमेज फॉर्म करता है बहुत अच्छी. तो नेक्स्ट इज साइड एंड रियर व्यू मिरर ऑफ अ व्हीकल. कॉन्वेक्स मिरर, दिस इज बिकॉज ऑफ द लार्जर फील्ड ऑफ व्यू, लाइट को स्प्रेड कर देता है एंड हमें लार्जर फील्ड ऑफ व्यू मिलता है देखने के लिए. Solar furnace is basically we are using concave mirror because concave mirror क्या करते हैं, सारी की सारी लाइट रेस को एक ही पॉइंट पे कंसंट्रेट कर देता है, राइट? अगर हम हाफ ऑफ द मिरर को ऐसे कवर्ड रखेंगे किसी भी ब्लैक पेपर से तो क्या इमेज फॉर्म होगी? Yes, the image will be formed. As I have told you in the very first lecture of this light chapter कि हर एक पॉइंट ऑब्जेक्ट का लाइट रेस रिफ्लेक्ट करता है. हर एक पॉइंट से ऑब्जेक्ट के लाइट रेस जाती हैं, राइट? सो अब जाएंगी तो क्या होगा, हर एक पॉइंट ऑफ मिरर पे भी हर एक डायरेक्शन में जा रही है तो यहाँ पे भी कुछ लाइट रेस जा रही होंगी, राइट? अब बट वो लाइट रेस आगे इमेज नहीं फॉर्म कर पाएंगी, एक जगह पे मीट नहीं कर पाएंगी बिकॉज ये तो ब्लैक पेपर से कवर्ड है. तो क्या होगा, कुछ लाइट रेस जाएंगी और वहां पे मीट करेंगी जहां से मीट करना चाहिए, सेम पॉइंट रहेगा बट the intensity of the image will be little bit decreased. इमेज की इंटेंसिटी थोड़ी कम हो जाएगी, लाइट की इंटेंसिटी बेसिकली कम हो जाएगी, ब्लर नहीं दिखेगी बट इंटेंसिटी कम हो जाएगी, लाइट कम लगेगी आपको उसके केस में। इमेज कंप्लीट ही फॉर्म होगी, इमेज ऐसा नहीं है हाफ फॉर्म हो जाएगी, राइट। दिस इज द डायग्राम फॉर केस। अगर हम नीचे से कवर कर रहे हैं, सो दिस इज द डायग्राम, राइट। The concept will be same in both the cases. So today we are going to do till here only. So I hope you have understood. And if not, kindly do it on your own once, by looking at the video, pausing it, making your own notes in your rough notebooks. Only then you can able to do it. एक बार में किसी को आज तक समझ नहीं आया, right? ये chapter. So you have to do it on your own by making notes. I can just help you out, right? Thank you and have a nice day. Stay safe and stay at your home and help your parents, please.